and get push. Time to relax. Ring, ring. What's that? Hello? Prod? Prod who? Prod's down? Oh no. Oh, I can fix this. I can fix this. I'm just rep on in. Def and test. Object G3725. I know. I'll just print it. Oh no. The console will know what to do with this. Oh no. Python debugger? Oh no. Oh god. Oh no, if only I had known. If only I had known. If only I had read Sussman. Howdy folks. I'm Jordan, aka Lambda, and I'm here to help protect you from the situation you just saw. I'm going to do so using some powerful techniques adapted from Software Designed for Flexibility, a book recently released from the MIT Press that I've been fondly calling the SICP School. First, we're going to implement one of Sussman's techniques called generic procedures in ClojureScript. Then I'm going to combine this generic procedure with Clojure's built-in implementation of this abstraction, multi-methods. Finally, I'm going to share some spicy thoughts, advocating for the use of an adapted, data-driven design principle when working in reactive applications. I want to kill the horrible practice of passing in functions as props into components. We'll start with a few disclaimers. I've selected just one of many techniques to demonstrate here today. I feel it's one of the more accessible ones. It's in Chapter 3, and it was even covered in former work of Sussman from MIT in SICP. So our intended audience here today is intermediate ClojureScript developers. So if you're already a pro, some of this might be review for you. And if you've never touched ClojureScript, some of this may not make sense. But luckily, these strategies are semantically extensible. You don't always have a choice in the languages you're working in. It'd be super great if you always had a compiler checking your types for you or a step-through debugger. But luckily, these techniques are applicable to any language that supports functional abstractions. Even Python. In fact, when I do write Python, I write a weird functional version that kind of looks a lot like this. The Python kids think I'm kind of weird, but I just tell them, try Clojure. All right. Remember this? This is what can happen when you pass a function into a component. And it's really easy and tempting to do, especially if you're new to these concepts. We pass functions into map, we pass functions into filter. Why not pass functions into components? And if you come from a React background, passing functions in as props is even considered best practice. We got into this situation because trying to do exactly that. The reason I feel as though these methods are less preferred in a ClojureScript application compared to a React app is because why would we throw away our biggest advantage? Which, in my personal opinion, is observability of the data via REPL-driven development. Otherwise, why not just use TypeScript or JavaScript, where you can just find the answer and copy-paste in working code from Stack Overflow, not have to deal with the tooling at all? So, how do we get the advantages of ClojureScript while maintaining the flexible dynamic abilities of higher order functions passed into components? Can we have our cake and eat it too? Allow me to introduce you to Sussman's generic procedures. A generic procedure is a function that can handle many different types of data. And you may have heard me say types. Well, how does this work in a dynamically typed language? like Clojure or Python or Ruby? Well, to quote the OG SICP, in particular, we introduced data-directed programming as a technique to allow for individual data representations to be designed in isolation and then combined additively, i.e. without modification. The important thing to note here is the word additively. So instead of a giant con statement, we will favor runtime dynamic behavior. And that way we get the advantages of extensibility at runtime, aka in your REPL. Functional polymorphism. The key advantage of generic procedures is functional polymorphism. Sounds complicated, it's not. We can illustrate this conceptually with the addition operator in Python. Notice they combine integers, strings, or really any data structures for which the plus operator is already defined. Here we see an example with the list. Wouldn't it be great if it was that easy in all languages? More advanced developers may recognize that this behavior can be accomplished with a protocol-based dispatch. But we're going to discuss variations in behavior even within the same data type, such as hash maps with different and changing values. This quality is especially important in the wild world of web development, and you'll see why shortly. So to demonstrate this concept, I'm going to use a real-world example from the company where I work currently, Omniway. We are a San Francisco-based startup with a small distributed remote team, AWS on the back end, Clojurescript and Reframe on the front end. And if you don't know, Reframe and Reagent are just wrappers on JavaScript's React. Part of our product includes an in-browser shopper app. The shopper app allows shoppers to purchase products from luxury brands directly from the live stream event. Looks kind of like this. Kind of like QVC, but way better. And marketed towards luxury retailers. So Marni, All Saints, Valentino, that sort of things. We need to have a tight looking application. Feature development. Flexibility requires good architecture from the ground up. It is a lot harder to add on an extra floor to a building after the fact than it is to just build it with insertable floors. It's probably why I'm a software engineer instead of a civil engineer. So, have you ever gotten a feature request that started off kind of looking like this? As we all know, in the fast-paced land of the startup, feature development and requests are constantly evolving. Tickets and features are always living documents. Add in a remote team from different time zones, from California to the East Coast, all the way to India. You need to be able to develop features in a way that is flexible, extensible, composable, and maintainable, because this can very easily turn into this over the course of a 2-hour meeting. Were you even there? Did you even see the Gmail invite? So the initial ask for this was to create an RSVP flow to enable shoppers to sign up for alerts, add to calendar, share to social media. Some of the goals is we wanted to ask as little info as possible so we can increase event entry, because nobody likes it when you ask for a bunch of creepy information. We also wanted to be able to pre-populate the information where applicable. So if we know your email, we want to fill it in for you. Make it as seamless an experience as possible. A good product manager turned that flowchart into this guiding light ticket in the epic. So we're going to start with the RSVP page UI1, this view. Because we do reframe, this is kind of an idea of the data we have to work with. But because we're keeping this abstract from any framework, I've pulled it out and hard-coded the values for you. This is in a what you see is what you get sort of fashion. Normally, the values of this hash map would be populated via reactive functions, depending on the user's page state. So this is a form2 component, And when the values of this data change, this function is going to be rerun based on that change. Digging into the inner function here, in our let, we have the generic function implementation I'm about to build up and share shortly. This generic procedure looks at the data and simply returns a keyword. Then in the body, we'll use that keyword to render the current view using a multi-method. Some viewers may be wondering why we need generic components at all when we already have Clojure multi-methods. Well, because dealing with a situation like this, you'd just be shifting the burden of the conditional logic to the dispatch function of the multi-method. You then become a victim of your own complexity. I hear we're going to hear more on that shortly. Hi, Bug. So we're victims of our own complexity. We've somehow made a nested conditional logic more complex by adding a useless multiple dispatch layer on top of it. But you feel pretty slick though, huh? Well, I don't care how slick it makes you feel. You've just moved the burden over. You haven't solved the problem. There's even a special word for this, cyclomatic complexity. Remember, our goal is to avoid bucks. Ugh. No big ugly con statements. Which then, every time something changed, you would have to rewrite. This quickly becomes a source of bugs and a maintainability nightmare. So, how are we going to solve this? Generic functions. These are actually initially introduced in the OG SICP, and then they're greatly expanded upon and reiterated in the SICP goal. It's almost as though we didn't get it the first time around. All right, our generic function implementation. Let's dig into this bad boy. So this little buddy, this is a simple generic procedure in Clojurescript. First, we will use an atom to keep track of the registered views, and we tuck it in a let just to avoid it being exposed globally. This is a matter of personal taste. I just don't like globally namespace states like flopping around the namespace. All right, our first function, register view. We'll take a keyword and a predicate function and simply adds it to the atom. That's it. We're only adding things to the atom. We're not taking things out. Now, map current view. This chick is the backbone of the operation here. She looks at the data and returns the first view key in the registry whose predicate is satisfied. Now, keep in mind, keywords are not the only way to implement generic procedures, but register view is deliberately designed to have a visually similar API to def method, as you'll see shortly. So, remember this? That mess of possible different views? So each view corresponds with a page view in a product narrative. Each product narrative corresponds with the page state. Each page state could be represented with a hash map. Each hash map will be converted by map current view, that awesome chick in the last function, and return a keyword. So adding a new page view is as simple as registering a new view function with register view. Here we see an example of view register in action. Notice the visual similarity between register view and def method. Register view takes a keyword and a predicate function as an argument. Some of you may already be connecting the dots that this is a way to create a multi-method dispatch function with runtime dynamic behavior instead of a big ugly con statement. All right, so that was easy. We've implemented a generic procedure. And now we'll see how to accomplish dynamic page views by combining this with the flexible multi-method dispatch function with Clojure's built-in multi-methods. So we've taken our data, we've passed it to a generic function, and in that generic function, which is map current view, it takes the data and just spits back a keyword. Now we're going to wire up the generic procedure as the dispatch function to the component multi-method. to render a page view. Hopefully you're familiar with def multi and def method. Here you can see we register the function current view, and based on the keyword passed in an argument, render a different page view. In fact, each multi-method, as seen here, returns a reagent component that renders a page view for our OmniWay application. All right, this isn't a reagent talk, but just super briefly. The square brackets are important. They are hiccup syntax. They are used to visually identify components as separate from data functions. And it forces delayed evaluation of the component, so it can be dynamically re-rendered by reagent in responses to changes from data. Remember that Form 2 component? If that didn't make sense, don't worry about it and just check out the reframe docs for more information. All you need to know is that these values in square brackets render a page view. Note the RSVP public keyword in the associated component, which results in the page view here. Ta-da! This resulted because our state data was converted by the map current view function in our generic procedure to the keyword RSVP public. This is because it satisfied the predicate function for RSVP public. That results in the RSVP public keywords being bound to the current view key symbol. This causes our current view multi-method to dispatch to the RSVP public view along with the data payload. So what are the benefits here? Seems like a lot. You get new requirements for product, another page view. You just add another view to the registry. All right, maybe this sounds like a lot. And perhaps for only a couple of views, a con statement would totally suffice. I've heard this referred to as freshman dispatch, and it's very suitable for freshman problems. But for dynamic, high churn code, we need a more sophisticated approach. This is MIT, baby. It only took us 14 lines of code to implement this, much smaller than the big ugly con statement that it would take to implement the 15 plus eventually cases required for the final product. So in Software Design for Flexibility, there is a quote. This kind of extension is dangerous, but if we are careful, we can make old programs have new abilities without losing their old abilities. Yeah, sometimes all you need is a cond. But when it's a sophisticated problem and sophisticated feature, you need to break out the bad boys at MIT. All right, back to our techniques. We've implemented a generic procedure and combined it with a multi-method to return a component. Now I'll show you how to solve the problems we encountered earlier using the techniques we just learned. We turn our attention to the original problem. Remember this? The problem was that a function was passed in as an argument to a component. Just say no. Using the techniques we've learned, it will hopefully be obvious that there is never a need to do this. It's just as easy to pass in a keyword or a hash map as it is to pass through a function. Do you want to break prod? Because that's how you break prod. Instead, we will use a data-driven approach. So what do I mean by a data-driven approach? I mean, keep your data as data. Integers, strings, booleans, even better. Keywords, lists, hash maps. Don't pass through functions. Well, wait a minute. In Clojure, functions are pure data, Jordan. Well, yeah, you're right, technically. The rules are a little bit different in Clojurescript, though. We don't have things like static code analysis, type checking, the code navigation. You can't just MX jump to source on the onClick function. There's not really a useful step-through debugger. And you saw how functions looked in the REPL, right? And you don't even want to know how JavaScript handles nil. I'll give you a hint. Super willy-nilly about it. It is the Wild West out here, y'all. So if you do something like this and leave a breadcrumb trail of functions in your data, passing them as props to components, then sooner or later you'll find yourself in this situation, which very well may lead to this situation. Dun, dun, dun. So how do we fix it? Leave your data as observable values. Set yourself up with a nice layer cake of abstraction to then handle the values. If you do it well enough, you may even be able to recycle this abstraction cake in other projects. Instead of passing through the function, pass through the data in what you want to do. And then set up a multi-method on the end to actually do the function. So, stateful functions passed in a component as props, no go. But data and props used by generic functions, yeah, I like it. So we've done all this today. We've implemented Sussman's generic procedures in ClojureScript. We've combined with ClojureScript's closures, built-in multi-methods to render a ClojureScript component based on data. And I've told you why you want to use a data-driven approach, especially while working in ClojureScript. Couple more tips. Doc strings. I once heard a quote, "Hell is other people's abstractions." Be a nice coworker. If you're gonna do this, document what you're doing, follow your thinking. This kind of just goes for all your code. Also, keep a flexible mind. It's not a one-size-fits-all solution. This is one of many techniques that you should keep in your wheelhouse and apply where necessary. Sometimes a cond is all that's needed. In those cases, just use that. All right, I look forward to talking to y'all in the Q&A, and thank you for having me, ClojureD. I'd also like to thank and shout out to everybody at OmniWay, Rob, Icy, Abik, Ram, our QA team, Swaba and Nisha, and people turning all those flowcharts into tickets, Laura and Amitabh. Thank y'all. Now, if you enjoy this and you're wondering what's up with this girl with pink hair talking about Clojure, get out your phone, scan the QR code. That's all the places you can find me being funny and laughing and learning and nerdy. And there's a YouTube channel. There's a podcast. It's going to be great, y'all. You can email me, check out my website, Twitter. Let's jam. Let's talk. All right. Thank you. Bye.